All right. It was pretty. It made me laugh a lot. So what we're going to do today? Combined events. Let's see. What is it? 2, 11, 16. All right. And let's see. I think you guys know how to do this. I know, like, find the probability of tossing a coin and getting a heads. So, like, the probability of heads. And then rolling a die and getting a 6. So, like, what would you get? Like, what's the probability of tossing heads and rolling dice and getting a 6? So it's be 1/2 times 1/6, which is 1/12. All right. So you were good at that, right? Okay. Today's a little different. Today, instead of and, it's going to be toss a coin, get a heads, or roll die and 6. It's different. Why is it different? Yeah, what does that mean though? Like, why does that make it different?
You can choose one or the other.
One or the other. It's like this. You ask your mom, can I go out tomorrow night? And she says yes, but you have to clean your room and do the dishes. Instead, she might say, yes, but you have to clean your room or do the dishes. Which is better? No, which option is better? Or, because all you have to do is one of them and it satisfies the requirement. Here, you have to have both of them happen in order to satisfy the requirement. So the way this works, you see? You know where the 1/6 came from, right?
Yeah.
You know why I'm adding?
No.
Because this one will satisfy the condition, or this one will, but not both. You don't need both. You only need one. So if this happened, it doesn't matter what happened over here. You don't have to worry about it. If you rolled the 6, it wouldn't matter what happened with the coin. So it's either one. Bless you, bless you, bless you, bless you, bless you, bless you. Well, let's see if we can get a sense for that. We're going to do a little experiment. Hey, what color? Red, green, white. You guys are racist. You guys are racist. That's it?
You said red. This is white.
All right. So, there's the coin. There's the dice. So, am I understanding? I want to make sure I understand your question correctly, and I want to make sure you're understanding what I'm understanding. Why are we adding? Why don't we just say it's 1/2, or maybe why don't we just say it's 1/6, right? So the reason why is because either one of those things can happen, and it's fine. What does this equal anyway?
2/3.
Do you guys agree with that? You sure? You sure? 2/3. That's weird, isn't it? Huh? Because this would be 3/6, right? So that'd be 4/6, and that reduces to 2/3. Okay. So I agree the probability is 2/3. So should it be more than likely to happen with the or? Like, let's say let's talk about like what we did yesterday with expected value. Let's say this is worth $10 if it happened, and this is worth $10 if it happened. Which one would you try? The or, for sure. It's far more likely that you're going to get $10. You're going to get, on average, 2/3 of $10. Here you get 1/12 of $10. Right? Okay. So let's do a little experiment. I want you guys to get a feel for why you're adding here and why you're multiplying there. So, ready? Tails. So this one already a fail, right? Let's do pass fail. Pass fail. So this one, because we had to get heads, right? So this one's already a fail, right? Okay. So they're both fails. Dang. Okay. Ready? We'll do the dice first. 6! Woo! Pass. We don't know yet. Has to be both, right? Okay. Fail. This one already passed. Do you see what I mean? It already passed because it doesn't even matter. What we rolled the 6, so it didn't even matter about the coin. All right, next one. Hate my life. It was tails. So fail already. Oh, failed. All right. Up, failed. Let's see if we get heads. We win. All right, you ready? Heads. We win. All right, ready? Heads. Win. We don't even know what this one is yet. Let's see. Wait, what? What are you talking about?
You put the dice and the two.
It's because like we're doing it together.
I'm doing both at the same time.
Because like if you get a 6, then you have a chance of winning the first one, but you can still technically just won the second one.
Yeah, I'll show you what I mean. Yeah.
You won it because you got 6.
So check this out. 3. I don't know if I won this one or not yet, because I still have a chance to win this one. But this one failed because I had to have both things happen. So I'm doing both experiments at the same time. Okay, now, oh wait, that was worse than ever. Ah, win! See, check that out. Do you see why that you're adding these and these you're multiplying? When you're adding fractions that are less than 1, but they're positive, okay? Because the probabilities are between 0 and 1. So if you're adding probabilities, do the probabilities go up, go down, or stay the same? They go up. What about when you're multiplying them? They go down. Because they're less than 1, so the denominator is going to be bigger. When you multiply them, the denominators keep getting bigger. Right. Because they're less than 1. So this gives you a better chance, and that's why you're adding it. Does it make sense, kind of? I know it's not a very mathematical explanation, but you wouldn't like me if I gave you a mathematical explanation. And I don't think I could right now anyway, because I haven't thought about it for a while. And I'm really tired. And I need a little coffee. Oh, this is good coffee. The coffee that I have, it's from, alright, African coffee is the best coffee. It's the most flavorful. It is. And this coffee is what's called unwashed, which means like coffee looks like little cherries. And usually what they do is when the coffee's ripe, they take it off, they pick it, and then they spray it really hard with high pressure water to strip all of the flesh off of the berry. And then they roast it. Now Starbucks burns all theirs. They really do. Like what they do is if it's a low quality bean, it doesn't have good flavor. So what they do is they caramelize it too much to try to make it taste flavorful, but all you're tasting is burnt. Like literally you're tasting that they burned the bean. That's what makes coffee really dark. They don't do that if it has high quality beans because they taste really good, and all you need to do is just cook them a little bit so they don't rot. So anyway, this was called unwashed, which means they pick the berries and then they leave them and all the skin just rots off forever until it's all gone, and then they make it, and it tastes really good. Yeah, it's expensive. What's that? That's Savaya. Yeah, in Tucson. All right. Oh, wait. Let's do this before I forget. The difference between and or, because that's what's going to cause you trouble. I think you got it now, but if what you learn now you can't remember tomorrow, then it didn't do us any good. Let's write down in your notes what the difference between and or is. So, what is the difference between and or?
And both or just one.
Both and either one. Doesn't even matter. Just one of them. That's it. That's the difference. And so, and is more difficult, and it's got a lower probability. When I was a student and I would forget how to do stuff, I would use facts like this to like check my work. Like I'd set up, like if I had extra time and I wasn't sure how to, which way you set up and or. Like let's say I had an and problem and I forgot how to set it up. I would remember that if it was or, it should be bigger. and then I would like do another problem that was similar but different, and that way I'd know if I was right. And this is easier to win. Greater probability. Good to go? All right. You ready, Christina? You sure? Okay, Christina. Check this out. Let's say there's two spinners. You know what a spinner is, right? Like, what games use spinners? Life. Twister. Shoots and ladders. Yes. So, check this out. Spinner A has numbers 1, 2, 4. The word 2 is weird when you're talking about math class. Because if you didn't see what I wrote and you listen to what I said spinner 1 has numbers 1, 2, 4. Which if you were just listening, like if you were a blind student, you might think it was the number 1, the number 2, not the number 3, but yes, the number 4. Yes. Right, 1 through 4. In fact, when I did this, when I wrote the notes for the class, I wrote the word from right here. But I didn't right now. I wrote goes from 1 to 4. See? Yeah. Yeah, you know why? All right, there's a lot of study that says that you learn more when you're writing the notes. Like they've done studies where they compared people typing notes versus writing notes by hand, and the retention for writing them is like 4.5, like 450% or so higher than if you type it. So if I just put it up here and you just copied it without listening and like participating like with how I'm writing it, you would learn much less. That's why. Besides, I have beautiful hands. All right. You okay, Alex? A little sleepy? All right, so here's what we're going to do. This is, I got the idea for this problem from a Cambridge test. And when you take for your probability quiz, I think you have a problem like this, but I'm not 100% sure. I don't remember. I think so. Anyway, so you've got two spinners. One goes from 1 to 4. The other goes from 1 to 5. And step 1 says it's going to make a chart of the outcomes. Problem number 2. You know how they're like layered problems. Sebastian, you like that color? Yeah. Problem number 2 says, how many outcomes are there? There's 4 problems total. Number 3 says, what's the probability of a double 2? And number 4, D say, oh boy, this one's confusing. Does the probability that A equals 2 times the probability that spinner B equals 2 get the same answer as problem number 3? This one's weird, but it's not too bad. Do you guys know what the chart's going to look like when you make it? You're going to have one spinner go across like the horizontally and one spinner's outcome go vertically. So like it would look like, I'll do it the same way I did it earlier. So we're going to have like A goes this way and B goes this way. Right? So 1, 2, 3, 4, 5, because spinner A goes all the way through 5, right?
Yeah, me too.
That's big.
Sorry. 1, 2, 3, 4. Sorry about that. So you guys know how to use this chart? No? Well, how much area is in here? 20. How many total possible outcomes are there? 20. Because look, you could spin a 5 and a 2, which would be this one right here. You see? You could spin a 2 and a 4. So it's like this. It's like this would be 1, 1, of course, right? Which letter are we gonna put first? A's or B's? It doesn't really matter. You pick. A, and A goes down, right? So then 2, 2, 2, 2, 2. So you see how this would be 1, 2. You see what I mean? So it goes like A, comma B. Do you see what I mean now? And so this would be all the 3's. Like, let's say you spun spinner A first, you got a 3, then you could get a 1, a 2, a 3, a 4, or a 5 for the second one. So do you see that there are 20 outcomes because there's 20 spaces on the chart? Yeah. Sophia, do you see now? Just kind of get an idea how it works. So the answer, so number 1, we've got that taken care of. Make a chart of the outcomes. If this was a Cambridge test, I think that's worth 2 points, but I don't remember for sure. Might be only 1. It's pretty easy. Let's call it 1. Okay, how many outcomes are there? 20. Oh no, the answer is 20, and it's probably worth 1 point also. So there's 20. Mia, are you good with why there are 20 outcomes that are possible? Okay, good. How about Alexis? Okay, look, this tripped me out right here. Alexis hates it when I stamp her hand. And I tricked her again. And then Mia hates it when I stamp her hand. And I used the same trick 10 seconds later on Mia. And got her. Oh my goodness. Alright. And then, 15 seconds later, got America. Wow. Okay. Hey, what's the probability of getting a double 2? Do you guys agree with that? Because if you look, I mean, this is really easy if you use the chart. You don't have to set up a whole bunch of math if you have the chart. So it's kind of nice. Probability is actually a huge subject. And it's a complicated subject. It's a lot of fun, but it's really challenging. But Cambridge is really, they have a very small focus. And so a lot of times they make you use a chart because it makes life easy. So they like give you problems that you can set up with a chart. That you can, yeah. So anyway, you see how there's only one way? It's right here. That's the only way to get a double 2. So that's 1 way out of 20. So the probability of a 2 and a 2, 1 out of 20. Are we good? Hey, it doesn't ask this question, but what's the probability of getting a 4 and a 3 in any order? So 4 and a 3 in any order. Doesn't matter what the order is. What's the probability of getting a 4 and then a 3? How'd you get 1 out of 10?
No, 7.
1 out of 7?
7 out of 10.
7 out of 10.
14 out of 20, 7 out of 10.
Okay. How'd you get that?
I just counted.
You counted what? How many ways can you get a 4 and a 3? I thought there were 2 ways to get a 4 and a 3. I think what you heard...
Has a 4 or
Ah, yeah. Sophia, you know what? I know that you made a mistake, and I'm glad you did, though. You know what you did wrong? You mixed up and or. If this was or, I don't know why you guys are all, it's not a burn.
Shots fired.
Oh, that's why, yeah.
Casualties.
No, actually, I'm really glad you did that because it brings up again how easy, because you're a very smart student, you're going to get A star. It's very easy for even the really smart students to mix up and or. This is and, which means it has to be a 4 and a 3. The thing is, it doesn't matter which one's first. Do you see what I mean? So there are 1, 2 ways. So it's 2 out of 20. Or 1 out of 10. Right? This probability is like the only time where it's kind of acceptable not to reduce. Because a lot of times they have to do more and more math, and then they have you combine these probabilities. And if you don't reduce, they usually already have a common denominator. Okay, let's talk about number 4. So what's the probability that spinner A equals 2?
No. Yeah. Sure.
1/4?
Yes.
You sure?
Or you want 5?
Okay, what's the probability that spinner B equals 2? 1/5. If you take the products, does it equal the answer for number 3? Really? What's the answer for number 3? 1/20th. Is that 1/20th?
We got our 220 right now.
Yeah, I know. So the answer is yes, it does, right? Yeah. You know what's weird about these problems for me, bless you, especially when I'm taking a Cambridge test, is they're kind of weird. I'm not sure where they're going, and I'm not sure if I'm doing it right, and I'm not sure about a lot of things, and so it makes me hesitate. But yeah, you just be careful and do what it says, and then yeah, you'll be all right. So, how many guys are you comfortable making one of these charts now?
Yes.
Yeah. Okay.
If we had to make a chart, would it say make a chart?
It would say make a chart.
Sometimes it makes you assume that you have to.
I don't think so. You know, all right. There's other ways to figure this out. These problems without a chart. The chart makes it easy. On the I don't know the answer to that question for sure. All right. So next up, we've got. That's right. Christmas. Christmas. What's your question, Mia? I want to know your question. Oh, what's her question? Tell me your question, Alexis. The 4 what? Oh, how do you do this one? Okay, so did she tell you that you have to find the probability that spinner A is 1/4 because spinner A could be 1, 2, 3, or 4? Like by itself, not even worrying about the other spinner? It's just 1, 2, 3, or 4? Because it's not saying with both of them, it's just the one spinner. And this one's just the one spinner, which is spinner B. Spinner B goes from 1 to 5. Do you see? So to get a 2 would be 1 out of 5. Yeah? You sure? Why didn't you ask the whole class? Because you're shy? Are you shy? You're not shy? You just like Mia more than everybody else. Mia's your most favorite person in the whole world? Yes. Mia's like, yes. All right. Fair enough. All right. Here you go. You got a red die, you got a green die. The experiment is that we add them, so like this would be 10. You have to make a chart of all the possible outcomes, and then you have to answer those questions. How much time do you think you need? 10 minutes?
What they said.
10 minutes? I think 10 minutes is good.